Okay, value of R. Hopefully that's an easy one. It's just this version, the decimal version of the APR. That's our R, 0.125. 2 points. Okay, the monthly growth factor, well, this is the annual rate, and we know that when it comes to compound interest, we start by just chopping that rate up into however many times we compound per year. In this case, that's 12. Okay, so that's still going to be a type of percent increase, but as a decimal, so to get the growth factor, we add 1 to that.
No, if we have that.
So what is that value?
1.0104.
Okay, so either are fine. 1 plus R over 12 or 1.0104. Okay, so if this is the monthly growth factor, how do we get the yearly growth factor? We're going to take that and raise it to the... So if every month we multiply by this, and there are 12 months in a year, then every year we would multiply by 12 of those. And what is that?
1.132.
Okay, I'll just stop right there and ask any question. Are there any questions so far? Yes, sir. Nope. Yeah, expression is good enough. Now, for this next one, you kind of have to. This next one, you kind of have to. It's hard to see, unless you're a genius, what the APY is from that, but we can see it from this. So given that the yearly growth factor is 1.132, what is the percent increase per year?
13.2%.
Right. So why isn't it 12.5%? Why isn't our money growing 12.5% per year? Yeah?
Because you broke it down into months, so it ends up giving you a bigger percentage when you add them up.
Yeah, we started by dividing that into 12 equal parts, and then we let the interest grow on the interest every month. The effect of that, the yield, so this thing called the yield, the annual percentage yield, is the effect of chopping it up into 12 and letting the interest grow on the interest 12 times. In effect, we really get 13.2% every year on our money rather than 12.5%. Does it make sense?
You increase by 7.
In this case, 0.7%. Yeah. Okay, 5-year growth factor. So if the 1-year growth factor is this, so that's what we multiply our money by every year to get the new amount of our money. So what would we multiply it by every 5 years? That whole thing raised to the 5th. That's the 5. And what is that?
1.86.
So what's the 5-year percent increase? In 5 years, we increase our money by 86% every 5 years.
Wow. That's good.
It's good.
Nice.
Okay, so then what's the total amount that 10,000 would grow to in 5 years?
18,600.
Yeah, if that's our 5-year growth factor and we understand what that is, that's the multiplier that will give us the new amount in 5 years. So we just take 10,000 and we multiply it by that. $18,600 what?
$8.70.
03.
Yeah. Oh, 3. Oh.
So with this, at 12.5% compounded monthly, we have a pretty good return in 5 years. So find me that investment. I want that investment. And today, interest rates are so low, right? They're keeping interest rates really super low because they fear inflation. So you won't find this investment anytime soon. If you have the idea right, it's fine. Yeah. If your thinking was right, that's fine. Okay, so if they're 2 points each, then add whatever total score you had, add 8. And make it out of 20. 8 free points.
Yeah, I'm missing the $3 in the same percents.
Okay.
So take what you got and add 8 to it. 8. So each one is
So if the APR, so results in an annual rate of R with n compoundings per year, how much is P worth in T years? Okay, so this is the general case of this whole thing we just worked through. So if you start with R and you have n compoundings each year, how much would an initial value principal P be worth in T years? Okay, so make sure your name's on the quiz. Name and 170 and date. Name, 170 and date. And the date is the 12th, 10/12. Don't fold these. And you can just leave them where you're at. No, let's pass them. Let's pass them to the left. Keep your eyes off other people's scores, if you would, please.
I didn't even know.
And just make a stack over here. Okay. So now that we've been through this a few times, can we come up with how much is P worth? We call it A. A is the amount of the account after T years. So can you write out what this rule would be? Given R, n compoundings per year, and an initial value of P, A of T would calculate how much the account would be worth in T years. Can you write it out? See if you can write it out.
Using R and
Yep. So, here's your hint. So what would it be? P times 1 plus R over N
raised to the n.
raised to the N
Raised to t.
and then raised to the T. But so it's not just a formula to us. Things have meaning. What is 1 plus R over N?
Your growth factor
Growth factor for?
in compounding.
For one compounding period. Every compounding period, our money, we can multiply the amount of money we have by this to get the new amount of money every compounding period. Okay? Then what about this? What's that? If we raise that to the N. What's up? That's the annual growth factor. That's what we multiply our money by to get how much money we'd have 1 year later. Okay? And then the whole thing in brackets to the T.
So how many
years?
The T-year growth factor, right? It's what we multiply our money by to get how much we'd have T years later. So therefore, just take your amount of money, multiply it by that T-year growth factor, and it'll give you how much it's worth T years later. Okay? So what I want you to do is, on page 157, page 157, I want you to do that chart right there, according to the information. But just do it for yearly, quarterly, and daily. Just those three columns. Yearly, the first column. Quarterly, the second column. And daily, the fourth column. Just, we won't do, for time's sake, we won't do the monthly column or the hourly column. All right? So the first, second, and fourth columns of that table on the top of 157. Go.
It's just a compound usually. Still be fine.
Who's Shaw?
He's up for the first one.
Okay. I wouldn't be mad with that grade. That's a good grade.
You could. That's like what do you get? Because that's the annual password. So that's this is a writing false answers. Writing false answers. That's easy. You're so false, so true. Basically, what was the percentage? Just not
Okay, and let's just do the first 3 years for each of those. Just do the first 3 years for each of those. It's going to take too long. So the first column, second column, and fourth column, just the first 3 rows.
because you only do it like 4 times.
Right? Yearly, quarterly, and daily.
First, second, and fourth column.
365. Right? 365 is 364. 365. take your growth factor, which is 1.08, and that percent is your see when they give us a yearly, that's that on all of these. Oh.
Homework still moving around? Where's the homework at? Got it? Okay, cool. Make sure you get your homework. So let me highlight. You're just doing these, okay? Just those 9. Just those 9 boxes.
Yeah, no. Wait, why did you have monthly not highlighted?
Oh no, did I do it wrong? Did I do 1, 2, and 4? Sorry.
Yeah.
Did I blow that? Sorry, my bad. Here, I'm doing it blue.
Looking at monthly, I'm like,
It's-
no, I did quarterly.
This is what I told you, right?
Yeah, I know. I already did it for this one. Yeah.
Okay.
Look, I'm working on this one now. Aren't you? Oh, you stupid.
Okay, the blue boxes, right? Is that what I said? Blue. Blue boxes.
Do that. That looks better.
No, you can't do that. My answer was completely wrong. Oh, you do like 2. Yeah.
Okay, so we got the general idea. Don't want to spend too much time just punching numbers. So first of all, do you agree with the 3 examples that I gave you there? Do those make sense in terms of compounded yearly after 3 years, quarterly after 2, daily after 3 years? Let's just check and see if that's what you were doing, first of all. Any questions? If I were to find the APY, I'm giving you, here's 3 possible things to look at. Black box number 1, black box number 2, or black box number 3. Which one would correspond to finding the APY? Which box?
Box 2.
So in which situation would it be helping us find the APY? Some people are saying box 2. What is box 1?
That's just the growth factor.
The growth factor for one compounding period, which won't necessarily be a year, right? Usually it won't be a year. What is box 2? That's the yearly growth factor. And this one is? T-year growth factor. So this is the one we want. So this right here would help us get the APY. So just you find that growth factor, and you're just getting the percent increase from that growth factor. That's your APY, or the true increase of your money in percent every year. Okay, can I erase?
So it doesn't change for each one of those then?
Yeah, it's totally different for all of them. I'm just saying which one of these would get the APY.
Which box? Not
Which-
which numbers?
Oh, okay, gotcha.
I see what you're saying.
So to get the APY over here, you would do this. Not this. Not what I had. That would get the APY for daily. Make sense? So now number 3 also works. Gives you the daily compounding APY. Okay, check your numbers.
Here.
Success? Some people are saying yes? Yes? Okay. So let's take a look at this. What happens as you compound the same amount of money? Let's look just right here at the 5 years. So we're going to look right here. What happens when you compound more often? You get more money, right? The more often you compound, the more money you get, because interest has more of a chance to grow on interest. So the more often so we just keep compounding in smaller periods, then we just get an infinite amount of money? Yeah? Someone said yes. Is that true? So the more often you compound, the more your money will just grow to infinity. You'll have as much money as our national debt.
Yeah.
Agree? Look at the numbers. Look at what we're doing. Look at hourly. What's the difference between daily and hourly? Yeah, it's like loose change, right? Loose change over 5 years. So, by compounding more and more often, does your money just whirl off to infinity? No. It seems to be doing what?
Leveling off.
It seems to be converging on a number. Do you see? So we get the difference between yearly and quarterly and monthly is somewhat of significant difference. It's at least in the dollars, right? So here we're getting, what is this? $17 more, or $16 more. Here we get $4 more. But now the difference between daily and hourly is just pennies. So where this is heading towards what's called continuous compounding. Meaning, it's kind of a theoretical idea where we're compounding every single moment. Every single moment we're compounding. And this is the idea of like hourly, or every minute, or every second, every half a second. So every single moment we're taking what we have and putting it back into the account so the interest can grow on the interest. So when you compound continuously, do you end up with an infinite amount of money? No, these numbers seem to be, like you said, leveling off or converging on a number. So with continuous compounding, what is n? How many times are we compounding in a year if we're compounding continuously? Infinite, right? It's like n is infinite. It's like every single moment of time we compound. So our formula isn't going to work, right? Because what do we have? 1 plus r over, now it's going to be over infinity, to the infinity. Okay? So when we have continuous compounding, we have to kind of rearrange things. And we end up with a different form of the equation, which is this. So when n is a finite number, we have the equation. But when n is infinite, or continuous compounding, the formula becomes this. P e to the rt. Okay? E is a number like pi. It is a fixed number. It doesn't change. It's 2.71828, and we can keep going. That's what this means. It's like a number like pi, which has a fixed value, and actually is an infinite decimal like pi is. Okay, so notice that this is the initial amount still. R is the annual rate as a decimal, and T is the number of years. This equation is the one we use for continuous compounding. Any other compounding, any of these here, we use the equation that we came up with earlier that includes the n in it, that has the n. 1 plus r over n to the n to the t. Yeah. Right, yeah. So it will have to tell you what your compounding is, and then that helps you determine how to set it up. Okay, so find the 5-year value. So let's find out what, after 5 years, at 8% annually, what $1,000 is worth compounded continuously. So first of all, what do you expect it to be? Someone make a guess. Anyone can make a guess at what we're going to get if we, so here's what we do if we, this is yearly, quarterly, monthly, daily, hourly. So what about continuously? How much money do you think? Okay, and greater or less than hourly? A lot greater? $14.91 and?
Let's go 99 cents.
Let's see, what was our jump here? 76 to 82 was 6 cents.
So 85.
Yeah, maybe 80, maybe 3 cents more, or even less. We'll try that. So try that. There's not going to be a big difference between hourly and continuously.
So the rate at which we
this is the annual rate. It's the value of R. It's the same value of R as before.
okay.
Same value as R as before. So what will it be in this equation? 0.08.
0.08. Would it be 1.0? Oh no.
It's R, not the growth factor. What will T be?
5.
5. And what will P be? 1,000. Now, in your calculator, there is built in this value of E, and when you hit it, it actually gives you the caret because it's a very common mathematical construct to have E raised to a power because E has to do with this exponential base, okay? So it gives you the caret when you do it. How do we do? What is the actual value? 8 what? 82. Okay, so it's really actually the same. So 82.
825.
Oh, so 83?
Yeah.
Okay, so one more penny. One more penny for continuous.
Round.
How would we find that? Okay, any questions on that? Yeah. Number of years. It's this T and R, or this T, R, and P are the same values we had before. So, what's the APY for? So actually, it's kind of like we've come full circle. What was our general form for an exponential equation? A times b to the x. So, a of x, a of t equals, what is a kind of like? P, right? Initial value. That makes sense. That's the initial value of our money. Okay? So if the input is x, what's our input here? T. Then what is b like? So it's really, we're saying that b is like what? E to the r. So this value, b, which is the 1 unit growth factor, is e to the r. So to find the APY, which is the percent rate per year, we would look at the b value or the e to the r. So find e to the, what's r? 0.08. That's like our b, right? That's like b. b is e to the r. And you get 0.08. This is the key. It's not 0.08. No, it's not 0.08 because we're compounding continuously. It's going to give us something better than 8%. 0.08, 3, give me 3.2?
32870.
So 3, how about 3.3?
Yeah.
So what is the, for 8% compounding continuously then, what is the true yield per year? 8.3%. 8.33%. That's the best we can do for compounding. We can't compound any more often than every moment. Okay? So 8% doesn't become infinity when you compound continuously. It approaches this, as you compound more and more often, it approaches this best case scenario, continuous compounding of an APY of 8.33%. You can't do any better than that if your annual rate is 8%.
And you're getting a penny more. By
Well, at 8% 4 or 5 years, you get a penny more. If it was 15% for 20 years, the differences will be greater. Yeah. So what I want you to do is try number 6 on page 159.
Just learn this equation. First of all, since to the 0.057, not 0.57,
Oh, yeah.
it's 57%. Percentage was a little off. That's out 10 times the amount.
okay, so the function, gives a population number of years since 2005. Let's call it f of t.
Equals 7.3.
Okay, so it's in general it's going to be a times b to the t, or since it's telling us continuously at a rate, then we have a times
E to the RT.
e to the rt. So the question is, what is a? Initial value 7.3. E is at fixed value 2.71828, etc. What is r?
0.057.
As a decimal.
0.057.
Yeah, thank you. Yep, I'm changing it. Okay, and then to the t. Population in the year 2015, what will you do? This would be t equals 10. Plug it in. That's easy. Okay, so now how would you get it in 2006? T equals 1.
Which is basically that.
Okay, what do you get?
7.739.
Let's do one more decimal place. 7.728.
Yeah, then it would be 2.
Okay, so if we started with 7.3 million and 1 year later we had 7.728 million, how can we get the 1 year growth factor? So we started with 7.3 and then 1 year later we had that amount. How would we get the 1 year growth factor?
Divided by 7.
Yeah, the multiplier will be the ratio. 7.728 over 7.3. What do you get?
1.0586.
Okay, now watch this. What's e to the 0.057? It's not the same number.
Not the same number.
What is it?
A little bit greater.
It's 1.05865.
1.05.
86.
Sorry, it is the same number. Sorry.
Well, then
What's the percent?
The next ones
Is
are
it 5? So you could raise
5581 and the other one is 30137.
Okay,
I tried like not two decimal, like I typed out 7.3 million. So I think that's what
okay. So the growth factor is what we multiply 1 year's amount to get the next year's amount. And notice this is the value of b right here. It's e to that number. So what's the true population percent increase per year?
5.86.
I thought it was increasing at, this is what trips students up all the time. I thought the population was growing 5.7% per year. Is it growing 5.7% per year? No.
Not continuously.
Because you have to take y. So the 5.7 along with continuous growth results in the real increase per year of this number. This is like the APY. The actual effect of 5.7% growing continuously, the effect of that is truly an increase of 5.86%. This is tricky for students. So I'm going to have to adjust the homework. There's some stuff we did not get to. And I also want to maybe add a few more problems like this. So when it's fully revised, there'll be a note on there that will say, this is the final homework, which is due the next time I see you on Wednesday. Have a great break.
For the testing, is there formulas or do I just like...
Oh, you got to know this. Because all the formulas are based on meanings, right?
Yeah, exactly.
Yeah. Did the homework make it to everybody? Where's the rest of the homework? Okay. Yeah. Yeah.
It was 49 and it just says which one is better.
Yeah.
So I think I set mine up for number 2. It says 100 monthly but per year for 10 years. So should I multiply the 10 by 12?
What's that inside parentheses?
That's for this rate that I'm not at that time.
It's a growth factor. What growth factor is it? Inside the parentheses. Monthly growth factor. So are we ready to go right to the 10-year growth factor? Multiply it by. Well,
Like for that.
so we got the monthly growth factor, then what do we need next? Annual growth factor, and then we can do the 10-year growth factor.
Okay, so
Yeah.
it would, okay.
Just like we just did.
Because I was like, why is that?
Right, way more. So the extra credit will be like, like before the exams, the web work stuff is extra credit. But really, you just do well in the exam. And the exam is a big amount of extra credit, right? You got to think of it that way. So it's just really the exams are what's important. So just start preparing early for the exam. Yeah. But there will be that web work again. 5.7%. 1% is different than a growth factor, right? Growth factor is the multiplier to get us the next new value. Okay? Percent increase is not the same as what you multiply by. That goes back to what we did a week or two ago. There's growth factors, those are the multipliers. You take an old output, multiply it by a growth factor, you get the new output. Now, when you do that, there's a percent increase. That's not the multiplier. Right? So like, if the growth factor is 1.03, you take an amount and you multiply by 1.03, you get the new amount. What was the percent increase? 1.03 growth factor. 3%, you see. So this thing, 5.7%, now you have to combine that with continuous compounding, meaning every moment we're recalculating and letting the interest grow on itself. So the effect of that over a year is to have, this is the growth factor. Right here. So continuous at 5.7% means that to get the amount 1 year later, you multiply by this, which is truly this percent increase.
So the 5.7% is the percent increase every moment.
No, it's still a percent increase for the year. But when you combine it with the continuous compounding, the result is that you truly get this percent increase. So you don't increase by 5.7% every moment. It is still a yearly rate, but it's what we call a continuous rate. A continuous rate is a rate that you have to combine with continuous compounding to get the actual yielding rate, which is this one.
I don't know where the E come from.
Where does it come from? We skipped over it. So if you want to see where it comes from, there's a derivation here that we didn't do.
Okay.
So this is, so it's basically continuing along this path, compounding more and more and more often, like every minute, then every second, then every millisecond. But if you compound every single moment, then n is infinity, right? So you can't use this formula anymore. So this takes you through where E comes from. We skipped over it. Does it help? Okay.
I didn't get my homework back from 2 weeks ago, and I'm positive I just did it.
Okay. It wasn't in the stack?
No.
Where are those other stacks? Thank you.